This year, online shopping made up 23% of growth in online retail in the United States. However, people often don't know what particular style of clothing they may be interested in, especially in an online setting. That is why we created Styled, a fully featured platform that detects clothing size and continuously recommends clothing tailored to the user's liking. First, users are presented with a prompt for their gender. This helps filter the clothing for men and women. The user then takes a photo of themselves from the waist up. The image is then sent to a server where a machine learning model predicts the user's shirt size. This AI calculates the width of the user's chest and generates the size letter using that chest size. We would also like to mention the creator of the library, Kashgra Chauhan. To consistently deliver the shirt size of the user, we first capture an image from the user's webcam using React Webcam. We proceed to send this image in base64 string format in a post request to a Flask server. The Flask server receives this base64 image and downloads it into a JPEG. We feed this JPEG into the OpenCV model, which outputs the chest size. We return this chest size, which we convert to size letters based on certain intervals.
Alongside with the AI, we have a smart, attribute-based recommendation system. This example piece of clothing is made out of cotton, has short sleeves, a swirl pattern, and the colors orange and pink. We categorize these traits as attributes. Each piece of clothing has a certain set of attributes that can be shared with other pieces of clothing that are similar. We use an API provided by Zappos to obtain clothing data. The data include the brand name, product ID, product name, price, and product URL. We also created and utilized a web scraping script that used Puppeteer to scrape the description of each piece of clothing and save the data into a JSON file. Then, using the data we scraped, we scan each description for attributes that we can assign to the specific piece of clothing. We save the general information about each product and its attributes onto a file store database where it can be pulled from anywhere in the world. When a user selects an item, we search all other items for shared attributes. The items are then ordered by the number of attributes they share. The user will start off with a large variety of clothing, but over time, they will only end up with the styles that they prefer. If you remember in our initial survey, we could choose between men's and women's clothing. In this example, I decided to use men's clothing. This item selection page contains a huge variety of men's shirts and tops. Each piece of clothing has different attributes that the user can see on the card. If the user likes a particular style, they can click on the card and our recommendation algorithm will automatically update the list. For this example, I'll be selecting all the cards with a polo trait. As a result of me selecting particular clothes, the algorithm is updating the list. At the very top of the list, many of the cards contain the polo trait due to our algorithm. After I am done selecting my styles, I will click Continue. When I click Continue, the website will return the first 100 results ranked by relevance. In the final selection page, the user has the ability to click on the desired product and visit the respective product on the Zappos store. For example, clicking on this short sleeve tan polo will redirect me to the respective Zappos product on the Zappos website. The user also has the ability to search through the page by name and brand. As an example, when I search for Under Armour, the results shown are all part of the Under Armour brand. The user also has the ability to sort through the clothing options. For instance, I can sort by price ascending, and it will sort the clothing options from the cheapest to the most expensive. I can also sort by rating. Sorting by highest to lowest rating will give me all the 5-star options at the very top. Be sure to visit our live demo, styled.vercel.app. That's styled with 2 Ds. Be sure to also check out our dev post and GitHub, which is going to be in the description.